Okay, welcome Cisco Cohort 2. This session is being recorded and will be placed later today in the recorded presentations link near the bottom of the Blackboard, my TCC Blackboard link for this class. On the schedule for today, we're going to be covering this lab 5.1.2.8, where we're going to look at that host PCA machine when it's plugged into the switch. What is this MAC address? We'll see how to find the MAC address by looking at the PC itself, and how to find it when it's plugged into the switch. On this lab walkthrough, I'm going to first get started with Packet Tracer using the great physical mode of the new Packet Tracer version 8, just to drag the wires together and get them connected. Then I'll actually do the complete lab walkthrough on my actual real equipment here. You guys here that are present here in the lab. Someone's joined us remotely. There we go. If you want to, you guys that are present here physically in the lab, you can do it on Packet Tracer, or I think you get more benefit out of it when you get your grabby-grabbies and the real equipment and use real switches and real PCs. Okay, so first of all, I'm going to bring up the Packet Tracer. And on the front page of the lab, it says we're supposed to get a switch and get a PC. So I'll get a switch first. I'll go down to the switch provision here. And I'll just, oh, I'm sorry, I'm going to do it in physical mode. It's better looking in physical mode. Then we'll come back and clean it up in logical mode. So I'm going to go to the top. I'm going to click physical mode. I'll open the home city. I'll open the building, the corporate office. And then we'll click on the main wiring closet room. And then I'll provision a rack for the switch and a desk for the PC. And then I'll take that switch that I was fixing to provision a second ago, and I'll put it up in the rack. Oh, you can let me do it. There we go. And then we'll provision the PC and put it on the desk. That's my PCs. Got to click on the PC devices. Click the PC, put it on the desk. There we go. Now let me sit back and blow this up a little bit where it's a little easier to see the wires that we're going to be connecting. Click that power strip, push it up so out of the way a little bit. And I'll make this a little bit bigger. There we go. I think I can make it a little bit bigger here because there's only one thing on the desk. So what we're going to do now is we're going to plug the two wires. Here in the physical lab, we have to have two wires plugged together to make this lab work. Oh, yes, I'm sorry. Can you close that door almost all the way, but leave it about 2 inches out? Teaching here is constantly a challenge because of the noise from the electricians and the noise when they're testing the fire alarms. Don't worry, we shouldn't have to bolt for the door today. So when you do this lab with actual real equipment, you need two wires. You need an Ethernet cable to go from an Ethernet port of whatever your PCA is. And we're going to be running our VMware, which is connected to a separate interface Ethernet NIC on our machines. And you need that console cable, that baby blue rollover cable, which connects to the console port of the switch, because we're supposed to place a management address on the switch to make so we can ping it. That first question is a trick question. It says ping the switch. Did you get a result? The answer is going to be no, because there's no IP address that's not been placed on the switch yet. So I want to go ahead and make those two connections. And the wiring diagram shows us the Ethernet connection. I'm going to click on the switch. I'm going to click on the lightning bolt, make a connection thing, and then we'll choose a copper straight through cable. And then I'll click on port 6 of the switch, and then I'll click on the Ethernet port of the PC device, and they're connected together. Now, there's one more cable, and actually in Packet Tracer, you don't have to do this next step if you don't want to, because you can just click on the switch and click on the CLI tab and go right into the configuration commands. But in the real world, you would actually have to connect the serial port. So let me go and click on the baby blue rollover console cable, and I'll click on the RS-232 port. But looky here, it's on the back of the switch. How can we get to it? Well, let's inspect the rear of the switch and plug it to the console port. So now when we inspect the rear of the switch, there's a plug plugged into the console port, and we'll be able to configure this device. Let me see. Can I minimize this so I can exit out? Oh, yeah. Okay, we've got them plugged together and configured. And if I go back to logical view, this is sort of what it looks like in the lab. We have I'll drag this up here. We have a PC connected to the switch. And the dark blue solid line is the Ethernet cable. And the blue line represents the baby blue rollover cable. So in Packet Tracer, there's really two ways to get to the command portion of the switch. To do this, I can simply click on the switch and click CLI. And that's a shortcut to get to it. If you were actually on real physical equipment, you would go to your PC, and in Packet Tracer, you would go to your PC and go to the desktop, and then choose the terminal program, which is kind of like hyperterminal, and click OK, and then you're connected to the device. So that's how you get started in Packet Tracer. Now, I'm going to minimize Packet Tracer at this point and go to the actual real equipment that we're going to use here today. Let me minimize the lab, minimize this. And so here's my Terra term. Let's see, what does he have to set up first? Are we going to do the switch or are we going to do the PC? Oh, we're going to do the PC first. We need to configure the PC first. So I'm going to go to my VMware, and I went ahead, booted up PCA. So it's going. And now we're instructed to set PCA, the IPv4 address for PCA. We're supposed to configure the IP address, subnet mask, default gateway. In this lab, there's actually no router, but they're just having us do it to get used to it. So I'm going to go to PCA and click on my shortcut that I provided and go to the properties and then go to IP version 4. And there's already an address in there from a previous lab. So the quick and dirty way in Microsoft Windows machines to get rid of that is to click the Obtain the button and then go, which is a dynamic mapping, and then click back on the static mapping, and then we can put in the address you request, which is 192.168.1.3. He automatically fills in the subnet mask for you, Windows does, and then we're going to put in the default gateway of our non-existent router, which is coming up in a week or two. We'll put routers in here. 1.1. Okay, I'm going to click OK. I'm going to click OK and click Close. On real machines, you have to click all those close, OK, close to make it take effect. So just to check, I'll type ipconfig. It looks like it took it OK. Okay, all the devices are powered on. I'm actually plugged into a real switch. It's actually powered on here. Just to prove it to you, I'm going to go to the Terra term prompt. I'm sorry. Let me change this font so it's a little bit bigger, a little easier to read. So here's our Terra term prompt. I'll put it up here somewhere. So it's up and up. If I do a show, IP interface brief, port 6 is up and up because our PC is plugged into port number 6. So we're instructed now electricians are noisy today. Okay, pretty good, How are you? So step 2, we're supposed to ping the IP address of the switch. So I'm going to go to the PC and I'm going to ping 192.168.1.3. Wasn't that what it was? Wait a minute. No, that's my own address. Of course my own address works. I'm supposed to ping the switch address, 192.168.1.2. So what I just inadvertently illustrated to you here is you should always be able to ping your own PC's address. That's its own IP address. What's the other address we should always be able to ping on the PC? Correct, the loopback address. Winner, winner, chicken dinner, 127.0.0.1. I should be able to ping that properly. Okay, so let's actually do what he asked us to do. We're supposed to ping 192.168.1.2, which is the switch address. And were the pings successful? They cannot possibly be successful because the switch has not yet been configured. Layer 2 dead link layer switches out of the box, factory fresh, have no IP address. Most of these switches that ship in the industry are never configured. They're just plugged into a company to plug the devices together so they can talk to each other. So we're going to go through the process now. Yes, what's up? You can't see the screen? That's the biggest file I can make it. I'm sorry. That's the biggest I can make it. So let's configure some settings for the switch and see if we can get, the pings were not successful. Explain, he said. Why? Why are the pings not successful? Well, there's no management address yet on the switch. Has not yet been configured. So let's go ahead and configure some basic settings on the switch, and I'll pull up the switch prompt. Yes, I can do that. I can do that. I can certainly do that. Let's set it to the night light mode. There, that's the dim version. That's the dimmest I can make them. We have our new LED lights because we got that $825 million bond election that was passed last November. So the electricians have been in this building for months and months and months now. It apparently takes a long time to change out one light fixture. Okay, so the switch has no configuration. If I go to the privilege exec mode, I'm not asked for any passwords. If I do show me the startup configuration, there's no startup configuration present. And what's the one other thing we're supposed to check on the switch before we go to work on it to make sure there's no previous configuration in there that might mess up and hose our configuration? The presence of a Vlan file, vlan.dat, is not there. If it were there, for example, port 6 and port 1 could be a different VLANs that could mess up your configuration. Okay, so I'm going to go to step 3, and we're going to configure the switch, and we're supposed to do some stuff here. I'm already in the privilege exec mode. I typed enable, so I'll type configure terminal. Are we recording? We're rolling? Yeah, we're rolling. I did that. Mic is on, camera's on, everything's cool. Now let's give it a host name. So host name S1. 1. What's going on here? Okay, configure terminal. He had a little nervous breakdown, but I think it's okay now. Host name S1. There we go. Now we're supposed to say no IP domain lookup in case we mistype a command. It won't hang up the machine for a couple minutes. Then it just showed us it's totally capable of hanging itself all by itself. No IP domain lookup. And that way, if I mistype a command, I'll go back to the command prompt right away. Now, here are the commands that are crucial for giving him an IP address, so we'll be able to ping it, etc. So if I go and look back at this show IP interface brief, which is a very useful command that we normally use to check a device, we can see that it has the VLAN interface. That's the management interface called the SVI switch virtual interface. That we're going to apply an IP address to that. So we'll be able to ping it. In previous stuff, we telnetted to a device using that particular IP address. So the VLAN is it's up and up, but there's no IP address assigned to it. Fast Ethernet port 06 is up and up. That's my VMware host machine PC-A. It's running okay. Okay, so I'll go to the global configuration mode and then say interface VLAN 1, the default VLAN. Oh, we haven't talked about VLANs yet. Don't worry, we'll get to that. Oh, by the way, if you're interested in continuing and getting everything for your CCNA objectives, in the fall, I'll be teaching the second and the third course. This course and the second and third course completely prepare you to get your CCNA, to pass the CCNA. We got cover every objective that's on there. And one of the things we'll talk about that in the first 8 weeks of the fall will be the VLANs. But try not to worry about that now. Okay, interface VLAN 1, and then the lab tells us we're supposed to apply an IP address to it, and that's that 192.168.1.2, 255.255.255.0. And then I'll do no shutdown. I think it was already shut down, but I'll just do it because he said to do it. So before I go to the next test and try to ping from PCA to the switch and vice versa, I'm going to do this command one more time, show IP interface brief. And we see he now has an IP address, 192.168.1.2. He was only a layer 2 data link layer switch. His only job is putting Ethernet frames around, which are layer 2 devices, layer 2 protocol data units. But now he has a management address. Now we can ping him. Now we can maybe, if we put in the code for passwords and stuff, we'll be able to log into him and use it. So before I do step 4, which says ping the switch from PCA, I'm going to ping PCA from the switch. If I can go one way, I should be able to go the other way. So I'll go ping, and the PC is 192.168.1.3. And it worked. We got success. Okay, now let's do what he says, and we'll go back to the PC. And here's my command before it didn't work, and now it's working. So the pings are successful now. They were not successful before because we had not yet established an IP address on the switch, so they couldn't ping that address on the PC. But now it's there, and they can both ping each other properly. Now let's look at this MAC address stuff, which is the really new topic information that we got in the lecture earlier in the week. So I want to look at the PC. I want to type the command. We have our short version of ipconfig, which just tell us the big three numbers. What's my IP address? What's my subnet mask? What's my default gateway? And then we're going to use the command ipconfig with a space and then /all. And that's going to tell us a lot of extra information, but what we're interested in here is what is the MAC address. Let me see, is this, hold on, minimize this. Make sure this is floating on. Okay, good. So the recording and the people that are being synchronously, oh, we have a, okay. All right, good. So the people that are being asynchronously can see me with my mouse and point out things. And when this recording shows up later, the people who are looking at us asynchronously at the recording will be able to see this. So here is our MAC address right here. And can I see if I can highlight it? I can sort of highlight it. So it's terrible, doesn't it? And we're getting brand new projectors over December. They're demolishing the room. New projectors, new desks, new cables. The rack stays the old. I don't think I mean new Cisco equipment, but the rack will stay. Our equipment's pretty good. It's only about 2 years old. So step one, on top of page 3, little letter A, use the output from the ipconfig/all command that I just now typed on PCA and answer some of these questions. What is the OUI? And that is the organizational unique identifier. That is, in fact, a vendor code. The first half of the 20, there's 48 bits in a MAC address. The first 24 bits is assigned to a manufacturer vendor that makes something. They're making something that has an Ethernet interface in it, and we're required to have this physical burned-in MAC address on each 48-bit MAC address, unique in the universe. So the way that we can make that work out administratively is, if you're a vendor or you're a manufacturer, you go to the IEEE organization and you reserve a bank of numbers with them. It's only $1,500, and they'll give you your own 24-bit prefix, and they'll put you in the master list of vendors, and then you can make 2 to the power 24 devices. And then when you make more than that, what's 2 to the power 24? Put on our binary hats. 5, 4, 3, 2, 1. And thank you for playing. We have some nice parting gifts for you. That's what, about 4 billion addresses or something like that. It's a bunch of addresses that you can make. And then once you make up all those devices, you can just go back to the IEEE and you can pay another $1,500 and get under the bank of a couple million addresses and make them. So the first 3 digits are here. In my case, it's 000C29 is a vendor address assigned to the particular vendor that for this VMware. What is the serial number portion? It's the last 6 hexadecimal digits. Excuse me. In my PC, it's ADC1BA. Usually when you're looking at something that's a hexadecimal type of value, you're going to see the A, B, C, D, E's, and F's in them. That's a good clue that it's a hex number, not a decimal number. Pardon me. So how can we find the name of the vendor that manufactured this NIC? And you can go on the web and look and put in a search engine and look for vendor codes, OUI codes, and they'll tell you that. And this is like going to either be one that's assigned to Intel because it's a fake Intel NIC, maybe it's assigned to VMware, maybe it's assigned to Dell because Dell actually makes the hardware that we're running this on. Okay, so step A was done for the screen print, and then step B is we're actually using the real devices here. Okay, so step 2, let's analyze the MAC address for this S1 Fast Ethernet port 06 interface. So I'm supposed to go get back again to the switch prompt, and I will type the command show interfaces VLAN 1. Now this is a long and boring version of show IP interface brief. Show IP interface brief really quickly shows us, oh, it's up and up and it has an IP address. Quickly, what I want to know, I can just look at that. This shows us a bunch of stuff, like how many have been many collisions and things of that nature. So what is the MAC address for VLAN 1 on S1? And it's right here. This is the actual burn-in address. So we look at this prefix, the first half of it, 5061 BF. That is assigned to Cisco. The IEEE took the $1,500 from Cisco and gave them that prefix, and Cisco could make a couple of million Ethernet interfaces in their boxes and send them out into the world. What is the serial number portion of it? It's the last half of it. In this case, it's the D78EC0. What is the organizational unique identifier for VLAN 1? Well, we could spend some time and go to the internet and look it up, but I can tell you that I know that this is a Cisco device. I'm using an actual Cisco device here. It's going to be assigned to Cisco. Now, Cisco has made more than a couple of million Ethernet interface devices. You know, most routers have 2 of them. So they have gone back to the IEEE and had to buy some more banks of addresses several times. So BIA, what does BIA stand for? MAC addresses, Ethernet addresses, burned-in addresses. BI stands for burned-in addresses, physical addresses, MAC addresses, hardware addresses. These are the 48-bit MAC address that's uniquely assigned to this Ethernet interface on this device. It could be a NIC card in the PC, could be a NIC adapter on a motherboard, could be our switch, could be a router, anything that has an Ethernet connection. Every single individual Ethernet plug on the device has to have a unique MAC address so it can be identified. Why does the output show the same MAC address twice? Because if we look at the screen here, it shows it here and it shows it there. The burn-in address is the address that's burned into the read-only memory. It cannot be changed. Now, in a later class, we're going to do some hacking fun with something called access control lists, where we can filter and permit and deny traffic based upon things like what kind of addresses does it have. So for the purposes of that, Cisco has a command in the iOS that allows you to change, instead of using that burned-in physical MAC address, you can change it to any arbitrary address you want to. The hackers tell me that on Windows computers, the burned-in address that's in the Ethernet adapter on that Windows computer is copied off the hardware, and it's copied into something called the Windows registry. The Windows registry is a place that stores all the dynamic information, like what color is your desktop, where your icons go, etc. And they tell me that they can go into the registry and change their MAC address so that I can't think of any good reason why you want to do that unless you were a hacker and you wanted to get away with something and hide your identity, you know, like using a fake driver's license or something. So in security, we got to be aware of things of that nature. Another way to display the MAC address is to use the command show me the, what's ARPA? ARP. Address resolution protocol is a necessary protocol in the IP version 4 land, because we normally, if one host machine like PCA wants to communicate with another host machine like S1, he knows 3 things, but he needs to know 4 things. He knows his IP address. He knows the other device's IP address. He knows his own MAC address because it's on his own circuitry burned into the ROM chip, but he does not know the MAC address, the physical address, the burned-in address, the hardware address, the Ethernet address of that machine he's trying to ping, that machine that's off of him. So he must ask for it. And he's going to ask for it by sending out a broadcast message with a special broadcast address of all ones. In hex, that's FFFFFFFFFF, 12 Fs. I only said 11, but it's 12. That's 48 ones, because F hexadecimal is 1111 in binary. That's a special broadcast address. Broadcast addresses are not learned by switches. Only real addresses. Unicast addresses are learned by switches. So once he sends out this broadcast to the other workstation, essentially he's like, calling all stations, if your IP address is 192.168.1.3, tell me what your MAC address is, so I can stop broadcasting so noisily and rudely on the network. And the machine he's trying to ping sends back his MAC address. And then he has the 4 things he needs. He has the 2 data link layer addresses and the 2 layer 3 IP addresses of both him and the other machine, he can complete the ping request. This is what typically causes the first ping to fail if you haven't done it recently, because this ARP correlation only lasts for about 3 minutes, and then it fades away if you don't use the machine. Because you could pick up your laptop machine that had a fixed MAC address and tear it to the library, and it has a different network address, a different layer 3 address, and he has to change that relationship. So it's not fixed, it's not built in. Now there's a trick with ARP where we can do things like servers and printers that are going to be around for 10 years and kind of lock that in place where it doesn't fade out. So when I type show ARP, it showed me my IP address, 190, I'm at the switch, I'm 1.2 and 1.3. I talked to him recently. Now I've been babbling on here for a couple of minutes. Let me see. See, it's 6 minutes. The routers and switches hold on to it for a little bit longer. Workstations normally hold on to it for a short amount of time. Do they tell us to do it on the workstation? I'm going to show you the command you can use on the workstation. So it's ARP-A, and he tells us the IP address of the switch. He's holding on to it for a little bit here. And those 224 and 239 addresses, those are multicast addresses, group addresses. IP version 6 has some groups that they join, but we're just going to deal with the unicast addresses in this particular lab. So at the bottom of page 4, B, little b question, what layer 2 addresses are displayed on switch 1? And let's see, we'll go back to switch 1. What layer 2 addresses are on switch 1? We have the layer 2 address of the switch itself, that's the 1.2. And tittle my mouse here, and 1.2 has the address 5061BF. That was the prefix, vendor prefix for Cisco, and then the unique serial number is the last part of it. And then 1.3, which is our PC workstation, he's 00C29ADC118A. And let's check on one thing here, because when you use VMs, let me see, I'm going to move this around a little bit. I'll try not to make everybody sick. 0029CD8. Oh, it matches. Okay. Sometimes when you use VMs, a VM has got its own, I call it a ghost MAC address. It's simulating an Intel card. There's no actual Intel card in this machine. It's a VMware simulation. That's a default DIC card you get when you install a VMware computer, a guest computer. In this case, they match. I have seen some versions of VMware where you end up with 2 MAC addresses. You end up with one MAC address that VMware thinks he is, and you end up with another MAC address, which is the actual physical address of the Dell motherboard that's on the computer. In this case, we're getting consistent results as if it wasn't VMs. Now, let's look at our MAC address table. And I'm going to see if I can make this a little bit bigger here. Will they let me make it a little bit bigger? Show me the MAC address table. And let's see, I think I've talked so little here, I've talked so long here, that there's no dynamic entry. So let me repeat that ping command. Get this to refresh. There we go. I had nothing but statics. There's some static addresses on the switch associated with all the 24 ports on it. And the switch, what did we talk about in the MAC address table in the theory and operation of Ethernet switching the other day? How long does he hold on to a MAC address in the MAC address table? Because you could pull it loose and go to some other, like your laptop or something you can move really easily. About 5 minutes. About 5 minutes. Around the same time as ARP tables are held on to. So I re-energized them. I did something, and now we have the MAC address entry for that number 1 entry, VLAN 1, port number 1. That's the port. I'm sorry, VLAN port 0/6 assigned to the default VLAN 1. And then after this, in the fall, we'll come back and we'll use some different VLANs. But right now, everything's the default VLAN, because when these switches ship out to business, they want to be like a single department all plugged together, not different departments. So does the switch, he says the question, does the switch display the MAC address of PCA? And there's our C29ADC18A address that we know now to be the address for PC-A, and we know for certain that PCA is in fact plugged into port 0/6 of the switch. And it's okay, it's plugged into port 6 and it's still there. It'll be there for about 4 more minutes now and then it'll be gone. Okay, I don't require the reflection questions, but let's just take a look at what they say. Can you have broadcast at the layer 2 level? If so, what would the MAC address be? The MAC address of a broadcast is what he means. So we definitely have broadcast in IP version 4 land. We sort of have broadcast in IP version 6, but they decided this is then but not the year 1999-2000. So the politically correct, feely, touchy people said, we're not going to call them broadcast anymore because broadcasts are evil and bad and they make you feel bad. So we're going to call them, we'll call them multicast or anycast or something like that. They're going to do exactly the same thing. We're just not going to call them broadcast anymore. So in IP version 4, we have the special broadcast address, the Ethernet address of all ones, FFFFFFFFFFFF, 48 ones is a special reserved broadcast address. Switches do not learn that. So switches don't bother to learn that because it's a broadcast. What are the 2 essential things that create broadcasts in an IPv4 network, a legacy-based network? ARPs. All day long, as you take more than a 3-minute break or something, you come back, it's going to have another ARP, and you're going to relearn your server or relearn your printer or whatever you do when using that machine. DHCP, Dynamic Host Configuration Protocol. When your machine turns on in the morning, and it's by overwhelmingly 99% now of machines in the field are DHCP, we click that a radio button that says obtain the IP address automatically, which means send out a DHCP broadcast, find a DHCP server, accept a compatible type of address that'll work with the network from that DHCP server, and now you can be part of the network, and that takes a second. So those are the 2 normal broadcasts. We get a bunch of DHCP broadcasts at the beginning of the day when people come in, turn on their workstations, and log in, and then we get a sprinkling of ARPs throughout the day. Why would I have to know, number 2, reflection question, why would I need to know the MAC address of a device? And the reason I would have to know the MAC address of a device is if I know his IP address, and I know my IP address, and I know my MAC address, but I don't know that 4th thing, I do not know his MAC address. If I want to send something to a host machine, I know his IP address, but I don't know his MAC address, how can I send it to him? Because I need to encapsulate that layer 3 information I'm trying to send to him in a layer 2 Ethernet frame, a data link layer frame. I don't have the destination address. That's the very first part of an Ethernet frame is a destination address. First thing out of the crack out of the barrel, I got to put that in first. I don't have it. So I have to send out a broadcast address. Everybody in the network, yeah, sorry to bother you by shouting into the broadcast, but if you happen to have the IP address 192.168.1.3, please send me back a reply and tell me what your MAC address is, because I have something I need to send to you, like a ping request, or I'm going to send my password and log into the server or something of that nature. So we need to know both the layer 2 MAC addresses and the layer 3 IP addresses of both parties involved in being a source and destination of any IP unicast type transmission. And so we use this broadcast stuff to do this. And IP version 6 has a different way. We have a request. Let's see. Show me, can I see the chat? The synchronous student who's viewing remotely, Ms. Martin, can you go ahead and send your request in the form of a chat message, and I can try to respond to this. Let's see, why am I not seeing all the messages here? Oh, I got it. The question from the field from a synchronous viewer, not here in the classroom, is I was not able to download the Terra app with the link that you gave me. Oh, I think she's talking about the one on my Cisco24.com site. So I will check on that for you, email you back and tell you that, and either attach it to you or find you a good way to do it. Because I think that she found out, I think that Ms. Martin found out that the TerraTerm download link that was in an earlier lab was a bad link. So to the best of my knowledge, TerraTerm was developed by a Japanese software developer, and maybe he changed his website or didn't pay his web bill or something of that nature. Okay, I'll check that out for you, and I'll get back to you on that, and I'll post that either back to you or I'll put it as an announcement in here. Okay, we've completed all objectives here. Oh, and so long as everybody's here, I want to go ahead and bring this back up again and mention that the Texas Network Academy Career Fair webinar, which is going to take place Thursday, April the 15th at noon. Might want to consider wearing the type of clothes that you would wear to a job interview in case they allow you to turn on your camera. Maybe someone will like your looks and like what your questions are, and maybe you'll be invited for an interview. That's just a bit of advice that I got from my Uplink Academy, the Education Service Center that's sponsoring this. You never know. The job market around here is pretty good, and there is a good demand for early career CCNA certified individuals. So check out the job market. You guys are in an early course. You guys are not quite early career yet, but check out the job market. We have 5 hiring employers who will be at the seminar, talk about the job market. Plan for your career, plan for the future. Do the things that's going to help promote your career if you're looking for a career in IT, particularly CCNA, Cisco type stuff. You know, have a LinkedIn account, go to Facebook if you have a Facebook account, and like Cisco Network and Academy, things of this nature. Okay, hang loose. I'm going to stop the recording. Mouse, obey me.